Good afternoon. This afternoon we're on site with Franco. We're at one of his sites in Johannesburg. Got a lovely sunny day. It's August. It's quite hot for this time of the year. We'll look at freestanding walls, and I want to discuss with you today some of the realities about dealing with the freestanding walls. Freestanding and boundary walls generally does not have any guarantees. There's a couple of reasons for that. One of the first reasons is that freestanding wall is not built with any DBC. So we've got foundations that's built into the ground, and this wall will quite often be prone to rising damp related failures. So it's almost like putting a sponge in a bowl of water, and that sponge will just soak the water up into the wall. So often we find at the base of the wall that there's a bit of damp. With freestanding and boundary walls, sometimes the ground level differs as well. So on the other side we could have a higher ground level, which means that we've got a bit of a retaining wall, and that will increase the likelihood of moisture, and moisture will rise above the opposite ground level. But typically speaking, around about 1 meter, gravity kicks in and the walls, the moisture would stabilize there. You can see here, typically we've got a bit of moisture related problem at the base. Our edge trimmers, when we use edge trimmers, we're causing physical damage to the wall, and it's allowing water to penetrate. And you can see normal movement and crack will also allow for some moisture to get in, but you can see quite often we find problems like this. In this case, the developer and the builder put in a joint, so about every 3 meters we want to have a joint to allow the wall to move a bit. So this is very good detail. We also want to make sure that the tops is waterproof, and here the developer used the membrane system, and you can see the membrane is intact and it actually looks very good. We can also use a fiber reinforced compound which doesn't incorporate the membrane. Newer technology, and it's actually preferred at this stage in the market because it doesn't leave this line. So typically this is what a freestanding wall would look like. You'll see I've got a sprinkler system right here at my foot. So another source of moisture ingress. You can actually see the fungal growth at the bottom there. But just remember, when you paint a freestanding or boundary wall, it actually is better not to put a very expensive elastomeric coating system on. It's better to put something that's breathable on, a pollen or a textured product. And typically you have to maintain your freestanding walls approximately every 4 to 5 years, depending on the condition and where it's located. So we're going to go and have a look at the preparation now. So we're on the opposite side of the wall that I just showed you now. On this side, you can see that we've got paving, but you can see the efflorescence. If you zoom in a bit, Franco, you can see that white powder that's on my hand there. Now this is what we call efflorescence, and when you see that white powdery residue coming through, it's normally a sign of moisture. So what this is, it's really the minerals and salts that's inside the plaster and the cement when we build, even in the bricks. When the wall gets wet and it starts to dry out, that moisture escapes the wall, and with it draws out the minerals and the salts, and it deposits it on the surface. So when you see that deposit on the surface, you know you're probably dealing with a moisture related failure, and there's an underlying cause for that. In this case, the underlying cause is really just rising damp, and as you can see, it stabilizes at a certain height. So on this wall it seems to stabilize there. That height is dependent on the moisture conditions, the water table, and even the fall of the land around the property. But as you can see, typical example of a freestanding wall with moisture related failures at the base. Okay, so on this wall, freestanding wall, we've done the high pressure cleaning. Typically speaking, when we do high pressure cleaning on a wall like this, we probably want to achieve at least 140 bar of pressure onto the wall, and we will systematically clean on the wall going from top to bottom, and where we've got a defect we'll turn it at an angle and try and expose some of the weak points. The other important thing to remember about high pressure cleaning is when you high pressure clean, we prefer to use a rotating nozzle that's actually got a bit of a hammering action. So often what it will do is it will just loosen the edges. So after high pressure cleaning, it's important to come back with a scraper and actually come and test the wall and remove all the loose flaking paint until you've got a stable surface to work on. So as a first step, we would start with high pressure cleaning. After that, we're going to start with scraping. We're going to rake open or hack open cracks, do crack repairs and blast repairs where needed. So this is our first step, high pressure cleaning. Right, we're going to have a look at the preparation on the freestanding wall now. Very important when you do freestanding walls or even made walls where we've got gardens or grass next to it, is to actually trench down. So you create a trench there, and we want to take our preparation and our application down to below ground level. So I very seldom see painters do this, but it's the right way to do it. So please make sure that we trench. You can see here the preparation. We've done the repairs, the crack repairs. We've used a modified repair material here, so it's got a latex modifier in to give it some strength, and you can see afterwards the guys will come back and they'll clean around the repair. What we don't want is we don't want any friable deposits. or any loose material on the wall. You can see this repair is extremely stable. There's no friable material left there. They will still come and clean it, but you can see the repairs are a very high standard, and because there's a modifier in there, it's actually quite strong. If necessary, we will redo the joints. In this case, the joint is pretty good. As I said, the developer did an excellent job here, so we're happy with that joint. From here on, the next step will be primer. So we'll come and put a masonry primer on here, and then if necessary, we may use a bit of fibre reinforced just to bridge some crazing or some uneven areas. And of course, if there was no membrane in play here, we'd make sure that the waterproofing is done with a membrane free system. In this scenario, although we've got a membrane, we will still use a fibre reinforced to bridges, because our life expectancy that we want out of this project would be in excess of 7-8 years. So we want to make sure that whatever we do now on the main units at least will go 7-8 years minimum. On the freestanding, I think if we get to 5-6 years, I think we'll do very well, but then we'll probably have to do some more maintenance. So that's what the preparation looks like, and I'll show you the finished products. Alright, so here's the finished product. So after the repairs that I just showed you, we put a primer on, and then we put the final color on. In this case, we're actually using a bit of a textured product on the freestanding walls, and we're achieving a very even finish, as you can see. So for a boundary wall, the standard is quite high here. This finish here should do the building very well. So that's a boundary wall from start to finish, and of course important to understand that they don't carry any guarantees, but if you methodically follow the processes from start to finish, then your boundary wall will perform very well. So thank you, Fransha, for your time, and thank you to you. I wish you a good week and hope to see you on site soon.